Good morning, ladies and gentlemen of calculus. We started talking about fundamental theorem of calculus, which is appropriately the biggest thing in calculus. And this is some of the notation. If you have like this function, small f of x dx, this is defined to be big F of b minus big F of a, which is the change in quantity over the interval. So we talked about what is the integral of a rate. What do you do to eliminate the rate? You integrate to eliminate the rate. And so that's what we see a real world use. So if it's a rate of something that's integrated, we find an amount from a rate. And what this looks like graphically is this. If you have a function here, f of x, something like this, and you have from some x value a to x value b, what we're talking about is if this is little f of x, the graph, what we have is we have this area here, and the area under the curve to the x-axis and bounded on left to right. And so sometimes you'll see these things called bounds of integration or limits of integration. So these are called bounds, A and B, bounds or limits of integration, or limits of integration. I had a very smart YouTube viewer a couple months ago who was questioning my use of because I just used the word limits here. And he says, shouldn't they be bounds? I said, well, yeah, technically you got me there, because you should say limits of integration. So if you just say limits, that's not technically right. So anyway, that's what this part right here is, this area. And we've been talking about indefinite integrals. This is an example of something we call we're going to talk about indefinite integrals. This is an example of something we call a definite integral. Thank you. Thank you for paying attention. And what happens when you do these, you're going to notice what happens when we work out a problem here. And so here's the first one we're going to look at how to do it. We have this one right here. We have our limits of integration. So our answer is going to be like this. And last week I had the Jason Foxtrot cartoon. Remember we talked about the notation in the cartoon? Remember that? Mm-hmm. Bob's Vegetable Garden. So let's go look at Bob's Vegetable Garden again. I'm not sure everybody was here. Did I bring up Bob's Vegetable Garden on Friday?
Yes. No. Is that your Friday?
We learned about the foxtrot.
Yeah.
Yeah, so you weren't here. You were here.
I was here, but we didn't learn about that. Hey, what are we talking about? We know about the foxtrot.
Okay. Yes, we're going to revisit. We're going to revisit Bob's Vegetable Garden.
Is that the thing?
Yes. It's okay, yeah.
Okay, here's the Bob's Vegetable Garden
Oh, look at that.
cartoon right here.
Problem in the story.
And so what they're doing is we're taking the integral of this function right here,
Top left.
which is what the area is going to be this function, which is y equals 20, from the limits of integration from 0 to 30. And when you integrate this, when you integrate 20 dx, you get 20x. And you see this little vertical line segment with the 0 at the bottom and the 30 at the top?
I see it.
That's what we're going to do. Okay, so it's going to look very much like this. So let's go back to our real problem that we're working on. So what's going to be our integral of 4x cubed dx? What's our integral of 4x cubed dx?
I got it. Oh, it's just x to the fourth, right?
Yeah, so it's going to be 4x to the fourth over 4.
Oh, 4.
Okay? Minus, what's this one going to be? 6x squared over 2. And so this is going to be, and what I'm going to do, after you integrate, as soon as you integrate, you got to go like this, 1 to 2, like that. And now, just simplifying, we have x to the fourth minus 3x squared, and then from 1 to 2. And what that's going to be is this. You take 2 plugged in for x to the fourth, so I'm going to put 2 to the fourth minus 3 times 2 to the fourth, and 2 squared, excuse me. And you're going to subtract out the same thing, but 1 replaced here. So you're going to have, and what I like to do is I like to just parenthesize the whole thing. So we have 1 to the fourth minus 3 times 1 squared. And so you simplify this out, I get 2 to the fourth, what is that, 16? So 16 minus 12. So that's going to be 4 minus, and what is this going to be? 1 minus 3. What's 1 minus 3?
Negative 2.
Negative 2.
Which makes it 2.
So you have, so your answer to this is going to be 6. Okay, that's going to be 6. And one thing I want to do as one last verification of this, I want to go to the calculator and just put it in there, make sure that's right.
Oh, no, I'm sorry.
Also remind to remind us of what calculator looks like as far as having to do this on the calculator. So does everybody remember how to get to this, how to get to the definite integral on the calculator?
I have nothing to do.
What do you press to get into the definite integral on the calculator?
Press mode.
Very aggressive.
You press math.
Math.
Math 9.
Math 9.
Ah.
So anyway, go to Math 9. Let's get out of this mode first. So I'm going to go to Math 9, which is find integral, and we're going to go for our limits or bounds of integration, 0 to 1 to 2. And here we're going to put 4x to the fourth cubed, excuse me, it's right, it's going to be integrated to the fourth. Yeah, thanks for catching that. 4x cubed, and it's going to be, what is the next thing?
Minus 6x.
Minus 6x,
Yes.
and we're going to go dx here. Dx, please be 6, please be 6, please be 6.
What if it was 7?
Thank you. What if it was 7? What I have to do is I have to go back and figure out where a mistake was made. But
Which was 8.
which happens, yeah, it would be something. But, so that's right.
Nice.
So let's go ahead and work on this some more. And so this one right here, as Kylie said, is called a definite integral. So definite integral is where you don't have the numbers. And basically, the reason it is a definite integral, the reason you come up with an indefinite integral is this, is that essentially, it kind of doesn't matter the elevation. The elevation, the c cancels out essentially of the indefinite integral. Because it's like this thing, the c will move this thing area up and down, but the net area inside there is still the same. And so hence we have a definite integral.
Oh, how'd that work?
Yeah, and so you don't have a plus c. You have an actual numerical answer. If you didn't have your bounds of integration, could you have a definite answer, a numerical answer?
No.
No, you couldn't, right? You'd have to have a plus c. So if you had an indefinite integral, you'd have to get additional information to find that value of the integral, but given our limits or bounds of integration, we can do that. Okay? So, what I want you to do is I want you to do problem 5. Okay, I want you to do problem 5 and then check it. You can check it using your calculator.
What in the heck?
So work it out. You check it using your calculator.
I don't know, Mr. G.
Oh no, man. This is going to mess you up.
Can I use the extra method of this?
I'm still a little confused.
No, this is going to mess you up. And I'm going to show you why. I don't know why they did this. This does not belong in this set.
I knew it.
We can do 6.
Yeah, let me tell you, I want to show you why this isn't going to work like that. Because what you have here, you have x, you're going to have x to the negative 1 power minus 4x to the negative 2 power dx. Is that right? Now, if we take x and add 1 to it, what do we get?
1. Or 0.
0, and what do we have to divide by? 0.
Oh, ew.
Yeah. Ooh. And whenever this happens, I want you to say, dun dun dun.
Dun, dun, dun.
So what's going to happen?
You know, anyway,
You
that's,
did it all,
so we have here is this next one here. You're gonna raise. You can have x to the negative 1, and you're gonna divide by negative 1. So that's gonna end up being like plus 4, and we go between 1 and 2. Okay, what happens is when you divide by 0, which is not defined, that's where you come up with. And so we have to have a different type of integration rule for this. And what it's called the natural logarithm. So if you take x, the derivative of the integral of x to the negative 1 power is going to be equal to the absolute value of natural logarithm of x. So that's what that is going to be, plus 4 over x between 1 and 2 is what that's going to be. And so you go ahead and put in, so you're going to have, I'll just work to the right here to leave room. So what we have is ln of 2 plus 4 over 2, and you're going to subtract out what's ln of 1. What's the natural logarithm of 1?
Oh, it's
Natural logarithm of 1.
I forget.
Okay, what power do you raise e to get 1?
0.
0. So this is 0,
Okay.
and then you have minus 0 plus 4. So you're going to subtract 4, and so you're going to have ln 2, and you're going to have plus 2 minus 2. So you have ln 2 minus 2. That's going to be your answer
Ew.
for this one.
Wow.
Okay, and so that brings in the logarithmic of the integration, and we can work backwards from this to, if we, the derivative, what do you think the derivative of ln, natural logarithm of x, is equal to? What do you think the derivative of natural logarithm of x is equal to? Guess.
The same thing.
It's this. It's 1 over x.
Oh, interesting.
Okay, so that's the derivative of that, of ln x. So the integral of 1 over x is going to be ln x. So that's it. Okay, let's go and Kylie recommended doing number 6. Yeah, do number 6. That's kind of a symbolic one. It's pretty good.
Bear with me.
Can I refresh your memory?
Yeah,
Well, we're not allowed to during the math period.
yeah, fine.
So- Thank you.
Okay, you all have.
I've got to read it.
Okay. Do you have an answer for this yet?
No.
I can give you another
7.
What you have here is this thing right here is equal to a plus 2b. So here, we can rewrite this thing as integral from a to b of f of x plus 5 integral from a to b of dx. So what is this thing equal to here?
A plus 2.
So this thing right here is a plus 2b. So here's a plus 2b. And this thing right here is what you're adding to, plus 5x from a to b. So what is this going to be? What is this thing right here?
Let me just plus
5a.
Or 5a.
Let's see, a, b, when I say b, it's b minus a. Yep, so 5b minus 5a. So what is this going to be here?
Negative 4a.
Your 4a plus
7.
7b.
What the heck?
So that'll be our answer to this one. So what happens, these problems are pretty easy. So what they do with these things here is they make little problems to kind of properly complicate these things for the rigor of a calculus student. That's what this is. Okay. Okay, here you're given a u-substitution. We tried to play a Kahoot game a little bit earlier, but that didn't work out because we didn't have internet service earlier. It looks like we have it now. We'll try to do that again tomorrow. So I want you to go ahead and do this u-substitution problem. 7. This is asking you, this is one where you don't actually work the whole thing out, but it's really the setup of it.
So it's just, it's like stuff on the wall, rather than trying to move. No. So, last
What do you have for this one?
C.
C?
I don't know, I think so. Good chance I'm wrong.
Okay, you say C, I'll say B.
Yeah, that's not the way to do calculus, to spread out answers between them. It's actually to calculate.
I actually think I
figure out-
got C.
Yeah, let's go ahead and look at it.
And it's talking crap.
Okay, so we'll say we'll have let u equal 2x plus 1, right? And then, so du is going to be equal to 2 dx. And so dx is equal to du over 2, right?
Wouldn't it be 2x?
Dx is equal to
Oh,
du
yeah,
over
uh-huh.
2.
I forgot to do that.
So already we know that d and e aren't looking good, right?
No.
Because we got to replace here.
Almost there.
And so what we have to do is take, now here's another thing that really throws upon you here, because we're definitely going to have square root of u, and we're going to have du over 2, so we're going to have that. But what about our limits of integration? How did that happen? Let's check it out. Now we are in u now, so u equals, we got to plug in 0. So if we plug in 0 for x, what do we get? What does u equal? 1. If we plug in 2, what do we get? 2 times 2 plus 1 or 5. So this would be our answer, which is?
I told you, Mr. Jimmy.
Good job, good job.
And you try to say I was guessing.
Well, maybe you weren't, but we're going to try to redo our Kahoot game tomorrow that has u-substitution. So I think that's a neat little problem, because one thing this does is when you actually have a definite integral with u-substitution, you have to change the limits of integration. So you got to take that into account.
And I drew 3 more.
Did you want to?
I drew 3 more.